This is the third type of geometric transformation as scaling. So here we are enlarging or reducing the size of a graphic element. So consider a triangle as a geometric element having coordinates P, Q and R. So we can reduce the size of this graphic element about origin. So this is the scaled triangle. This is called as a scaled triangle. Scaled triangle P dash, Q dash and R dash. This coordinate becomes Q dash, this becomes R dash and this becomes P dash. So PQR, it's a original triangle. Original triangle PQR. So after performing geometric transformation on this original triangle, we can reduce or enlarge the size of this geometric element. Okay, so we can enlarge the size of this geometric element. Okay, this may be the second scaled position. On the enlarged position we can see. So P double dash, Q double dash and R dash, R double dash. So here our aim is to find the coordinates of a scaled triangle. Okay, suppose consider a point P having coordinates x1, y1 or x comma y. So we are scaling this geometric entity means, or we are scaling the geometric entity if we are considering one of the point, means all points on this particular entity can be scaled with a scaled factor. So consider a point P x y. So here our aim is always to find coordinates of x dash and y dash. So x dash and y dash are nothing but translated or transformed points. Or to be very specific, we can say that these are the scaled coordinates. Scaled coordinates. In this case, we are enlarging or reducing this geometric entity about x and y axis. So in this case, a scaled factor has to be taken into account. This scaled factor is denoted by a letter S. So if you are scaling that particular entity about an x-axis, so this factor will be S suffix x. Similarly, if you are scaling that particular entity about y-axis, Sy is the scaling factor about x or about y-axis, sorry. So Sx into x as the original point, Sy into y will be the original point. Now here we have to convert these two equations in matrix forms as, so x dash y dash Can anybody tell what will be the elements in this particular matrix into this x and y? So we can say that this is a scaled vector. This one is scaling matrix. Scaling matrix, and this will be the original point before scaling. So what will be the coordinates in this particular matrix? Sx, second element is 0 and 0 sy. Now if you will multiply these two matrices, you will get the same result in above equations. See here, this Sx into x plus 0 into y. So this equation we will get 0 into x is 0 plus Sx into y. The second equation you will get. That means we can write this x dash y dash as, so p dash equals to this matrix is denoted by S, and this one as the original point. Okay. Now there are two types of scaling methods, or there are. So first is uniform scaling, and second is differential scaling. In this particular uniform scaling, we are scaling uniformly about both axes. Means scaling is same along x and y axis. Here scaling is different about x and y axis. Again, see, if a scaling factor Sx or Sy are less than 1, means size of graphic element reduces, and vice versa, Now what do you mean by this vice versa? Means if this Sx or Sy are greater than 1, size of graphic element increases. So size of graphic element increases. Now let us take an numericals on this scaling transformation. Suppose a rectangle ABCD, a rectangle ABCD having the coordinates A, B, C and D as 50, 50, then 100, 50, then 100, 80 and 50, 80. 50, 80. Having scaling factors Sx equals to 0.5 and S1 equals to 0.6. So tell me the students whether this particular image or graphic element will increase or reduce. Definitely the scaling factors are less than 1 means graphic element will reduces or that scale will be reduces. So our aim is to find A dash, coordinates of A dash. But before that you should have this as a scaling matrix and this one will be the original point. So to find the coordinates of A dash, so we are having this Sx 0, 0, S1. This one is our original point and 50, 50. So we will put values of Sx. Sx is 0.5, Sy is 0.6 and these points are 50 and 50. So matrix multiplication, see here this 0.5 into 50, so 0.5 into 50 plus this 0 into 50. Second element 0 into 50 plus this 0.6 into 50. So final coordinates are 25 and 30. Similarly, we can find the scaled coordinates of B dash, C dash and D dash. So for B dash, if you want to find B dash, simply you have to replace this particular matrix by this 150. So 150. So your coordinates will change as, see here, 0.5 into 100, so 50 plus 0 into 50, 0. So 0 into 100, then 0.6 into 5, so 30. Similarly, we can find the coordinates or remaining coordinates as C dash equals to and D dash. So C dash comes 50, 48, 48 and D dash 25, 48. Thus, scaling transformation is over. Okay.